Hey guys, so today we will be solving Leetcode problem 1043 partition array for maximum sum. So in the given problem statement, we have an integer array ARR and we need to partition the array into contiguous subarrays of length at most k. After partitioning, each subarray has a value changed to become the maximum value of that subarray. So if we have an array ARR, we need to partition it into subarrays, and after partitioning, all the elements of a particular subarray will get converted to the maximum element in that subarray. So it will get more clear afterwards. So in this way, we need to find the largest sum of the given array after partitioning. So we can see, since we need to find the largest sum, that is an optimal answer. We can think in the direction of dynamic programming. Okay, so what we are going to do is we'll write the recursive brute force approach, and after writing it, we'll simply memorize it. So we'll be using memorization DK. So this is the sample test case. Now let's look into this. So we are given an integer array ARR and maximum length of subarray as k is equal to 3. So suppose we create a recursive function util of I. Util of I is the recursive function, and util of I denotes the maximum sum that we can find till a particular index. So util of 3 denotes the maximum sum that we can get of this array, right? So in this way we'll find for 1 0 1 2 3 till n, and so util of n will be our answer. So util of I denotes the maximum sum we can obtain till index I. Okay, and util of n minus 1 will be our answer, right? So now a question arises, how we'll find this, right? So what we can do is we can try making subarrays of all possible lengths that are allowed at each index. So suppose we are at index 2, so we can try making subarrays of all lengths, that is 1, 2 and 3. So if we make subarray of length 1, then we can take 7 as it is. If we make subarray of length 2, then we need to find the maximum of these two, and 7 will get converted to 15, since the maximum of 15 and 7 is 15. And the next thing we can do is make a subarray of length 3. So since the maximum of this subarray is 15, all these 3 elements will get converted to 15. Okay, so what I am trying to say is, at any index I, we have k options, since we can make k subarrays. So largest sum that we can get till I minus 1 plus a of I into 1. So in this case we are making a subarray of length 1. Now the second option is to make a subarray of length 2. So we'll find the largest sum till I minus 2 plus maximum of ai minus 1 into 2. right? Since both the elements will get converted to the maximum one. Now this thing can be found through faith of recursion, right? The first one can be written as util of I minus 1 plus maximum of ai into 1, and the second one can be written as util of I minus 2 plus maximum of ai minus 1 into 2. And since we are left with one more option to make a subarray of length 3, we can make it as till I minus 3, and here we can do ai minus 2, 3, and this can be written as I minus 3 3, because we have subarray of 3 elements. Okay, so let's take an example. Suppose at index 4, so at index 4, 0, 1, 2, 3, 4, we are at here 2. So here we have three options to take 2 as it is. So first option, take 2 as it is, that is subarray of length 1, and find the answer till 9, that is index 3, through recursion. So util of 3 plus 2, since maximum of 2 is 2 obviously, and we have subarray of length 1. Now second option is to make a subarray of length 2, that is 9 and 2. So we'll find through recursion answer till index 2 plus maximum of 9, 2 into 2, because here 2 will, since maximum of 9 and 2 is 9, here 2 will get converted to 9, so 9 and 9, right? Now third option is util of 1 plus maximum of 9, 2 and 7 into 3. Since this time we are making a subarray of length 3. Okay. Now the answer at index 4 will be the maximum of all these 3. Right. So since we have k is equal to 3, we have 3 options. So if it had been 10, we have 10 options, and so on. So we might be getting a feel or a loop within the recursive function, so as to try all the key options, right? Okay, so I think we are good to go, and we can now code it up. So now let's make the recursive function. K is the maximum size of the subarray, and n is the index at which we are currently on. Okay, so if we have no elements left in the array, we can simply return 0, and we needed to try all the k options of making all the k kind of subarrays, right? For which we are going to run a loop. So before that, we need to initialize two variables, mx is equal to 0 and ens is equal to 0. So what mx will do is, it will store the maximum element of a particular subarray. Suppose we are at index 3. So we are going backwards from here. So at subarray of length 1, mx will store 9. At subarray of length 2, mx will again store 9, since maximum of 7 and 9 is 9. Then in case of subarray of length 3, mx will store 15 since maximum of all these three is 15. So for that we can do is mx is equal to mx e of 5. As the size of subarray increases, mx is also going to find the maximum till backwards. Then answer is equal to maximum of answer util a k n minus I plus maximum into I. Since all the elements of that particular subarray will be replaced by mx. So at first of length subarray of length 1, we have one element, so mx into 1. Then in case of subarray of length 2, we are having two elements. So like here 9, these two will be converted to 9 and 9. So 9 into 2. And here when mx is 15, all these three will be converted to 15. So 15 into 3, right? And one more thing, we need to take care of the array in the beginning, where when k is greater than n minus I. So if n minus I is greater than less than 0, it will go array out of bounds, so we can simply break here and we can return answer. Now let us call the recursive function. Since we are going from backwards, so n minus I, yeah, since we are at n, we need to find backwards. That is why I did n minus I. Okay, and after we are done till here, we need to find from 15. So after that I called from till from n minus I. Let's run this code. Okay, okay, wrongly called the function. It's working fine. Now let's memorize it. Since we are given a maximum length of 500, we can create a DP of 501. We can initialize it with -1. It's working fine. I think this should get accepted. Yeah, it has been accepted. Okay, so thank you guys.